So I have like so many questions for you on the inverse. So now we've talked about transfer of academic research from AI to neuroscience quite a bit. I have so many questions. Actually, I have even more questions going the other way from neuroscience to AI, but there's just no way we're going to have time to fit it in right now. So I think, and I'm putting you on the spot a bit here, but just between you and me, maybe we can do like a part two in the future where we specifically do the neuroscience to AI thing. So I'm just going to skip past that section for now and keep
Sure.
our audience excited about that for the future.
Sounds good.
Um, and then, so more quickly, and maybe it's something we can do in that future episode as well. We can talk about this more. Is this like emerging things coming out of AI and neuroscience um, research being combined together? So, specifically in a talk for the Center for the Neurobiology of Stress, which has a really cute name, CNS,
Yes.
which is the same as central nervous system. So it's funny. You proposed in that talk a thought provoking science fiction idea of directly propagating external cost functions into the brain via gradient signals.
Yes.
Um, and so that follows on pretty nicely from what we were just talking about, even if it is sci fi like. Do you want to explain that idea more and whether you still think it's possible?
I still think it's possible. And sure, let me unpack that a little bit more. So, as I said, I think that we now have clear evidence that in principle, there are physiological mechanisms in the brain that could support gradient calculations, that could be trying to figure out, okay, this is the direction I have to change things in order to follow that hill of my loss function downwards. Now, if that turns out to be correct, that indeed some of these physiological mechanisms that we've identified are doing that, then what you could imagine doing is replacing the brain's own gradient signals with gradient signals that you externally impose. So you then have a brain interface where you're stimulating particular dendritic segments that are, dendrites are the branches off of neurons. And one of the things that we've shown in our papers is that there are particular dendritic branches that could be supporting gradient calculations. So let's imagine that you then have a way of stimulating these dendritic branches in the brain, and you can basically give the brain gradients for loss functions that the brain doesn't have, but which you have in some external system. That would then give signals to the brain that would let it actually design itself to get better and change its synaptic connections to reduce this other loss function that you have provided it with. That would be very cool potentially for really seamless brain computer interfaces. So, one of the things that I think is worth noting is the way that this works right now in brain computer interfaces is we rely indirectly on the reinforcement learning mechanisms that exist in the brain. So, you know, we drop some electrodes into a person or a monkey's brain. We try to train them to control, say, a cursor on a computer. And the way they get trained is just that, the monkey will receive a little bit of juice when it moves the cursor to the correct area. The person will get some personal satisfaction when they do that. And so as a result, what the person's brain or the monkey's brain is actually trying to do is maximize rewards, and we're giving rewards that indicate the kind of thing that we want. But that means then that the credit assignment is indirect. As far as the brain is concerned, it's maximizing rewards, and that's the gradients that it's following. But we are giving rewards that are trying to direct it towards this other problem. But if, let's say, instead you were able to literally send the brain a signal about the explicit error on its cursor, like, no, 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 you overshot that to the left here, and now you run gradients for that error back through the brain using this sci-fi system I've described. You could imagine that like you would get to the point where you could control that cursor as easily as you control your hands. And it just feels completely natural. It's completely seamless. So I think there would be a lot of promise for this sort of sci-fi level brain computer interface that I have always dreamed of since I was a young kid reading Neuromancer. Uh, but I think that the interesting question about that as well is that it would mean it would bring with it a very difficult ethical conundrum, which is that part of what makes human beings naturally free, arguably, is that we all have our own internal cost functions, and no one can force a different cost function on us directly. The way that we force other people to do things is by tapping into their existing cost functions. So either by saying, okay, you want rewards, so we're going to give you rewards for doing the stuff we want you to do, or you don't want pain, so we're going to give you pain if you don't do the stuff we want you to do. But these are all indirect ways, as I discussed with the BCI, of getting the brain's reward function to ultimately do the heavy lifting for you. And it's just you imposing a particular reward function structure. But if instead you could really give direct gradients into the brain, you would have a situation where, for the first time in human history, there could be people where they're receiving an external loss function that their brains have not calculated themselves. And that would mean that it would almost be like a situation where the slave doesn't realize they're a slave, because it would feel like you were just doing what your brain wants to do. It's just you wouldn't be aware, or maybe you would, depending on how it was set up, that that loss function wasn't coming from you internally, but coming from this external source.